Hello, y'all. Go ahead and find page 3 of the chapter 11 notes, and we're going to go through this. You should have already filled these in, and hopefully what you're noticing is that because each of these regular polygons is inscribed in a circle, this central angle here is going to contain 360 degrees. So for a triangle, the central angle is going to be 120 degrees, because 360 divided by 3 is 120. Then for the square, you're dividing 360 by 4. So this is a 90-degree angle. For 360 divided by 5, you're getting 72 degrees. And then divided by 6, you're getting 60 degrees. And so here, all we did, right, was because each of our regular polygons is inscribed in a circle, which contains 360 degrees, we're dividing 360 by the number of central angles that we have going on here. So let's go ahead and continue. Go ahead, take a pause, copy this diagram right here, and then we will come back. All right, you should have copied this. So a couple of things. The center of the circle is also going to be the center of our regular polygon. A central angle's vertex is at the center point and is formed by 2 radii, okay? And then the radius goes from the center to a vertex. The apothem is going to be the perpendicular line to a side that also bisects that side. So those 2 pieces here are going to be equal. If we're good on that, then let's continue on to page number 5 and go ahead, take a moment to pause and copy what I have drawn in here, and then we'll go ahead and get going. All right, so you should have just paused, and now we're gonna look at how to find the area of each of these regular polygons. So if I'm starting with a radius of 8 inches, I'm gonna label my radius as 8. And then because this is a regular triangle, my central angle here is 120 degrees, right? So if I drew in another radius, this would be 120 degrees from here to here, which means then from here to here is half of that, making this 60 degrees. So now I have a 30, 60, 90 triangle if I'm looking at just what I'm shading in green. So take a moment, pause, using what you know about 30, 60, 90 triangles, find the 2 missing side lengths. All right, so now you've found that the short side is 4 and that the long leg is 4 root 3 using your 30, 60, 90s. If the long side is 4 root 3, then this piece here is also 4 root 3, which means that the whole base of our triangle is going to be 8 root 3. Now, if I want to find the area of my whole triangle, there are going to be 3 of these triangles that I'm shading in green. So my formula for area is going to be 3 of these triangles. And when I say these triangles, I'm talking about this whole big triangle in pink, okay? So we're gonna do 3 times 1/2 base times height. So 3 times 1/2 times the base of the whole pink triangle, which is 8 root 3, times the height of my pink triangle, which is 4. And then we are going to leave our answer in simplest radical form. I would cancel the 2 into the 8 first to get 4. And then 3 times 4 is 12, times 4 is 48. So 48 root 3. Do not drop your units, which from up here, we were given inches. And because it's area, it's inches squared. So now let's go ahead and look at the square that is inscribed. So now we're looking at this one. We're given A, the apothem is 4. So this is 4. So now let's fill in the rest of the information. So we know that the central angle of a square is a right angle. So that means if I were to draw in my other half of this triangle, then half of 90 is 45, giving us a 45, 45, 90 triangle. So now go ahead, take a pause, fill in the other two side lengths of this triangle in green, using what you know about 45, 45, 90 triangles. Okay, so when you did this, you should have gotten this is 4 and the radius is 4 root 2. If from here to here is 4, then from here to here is also going to be 4, making this whole base 8. And so now, again, if I'm looking, how many of, if I highlight in pink, how many of these whole triangles are there going to be that make up my square? And it's going to be 4. So now we're going to do area of the whole square is equal to 4 triangles. So I'm going to do 4 times 1/2 times base times height of, again, remember we're looking at the whole pink triangle, right? This whole triangle. And so then we can plug in. So we have 4 times 1/2 times the base, which is the whole base of the pink, which is 8, times the height, which is 4. And now we can cancel. I'd probably cancel the 2 into the 8 to get 4, and 4 to the third is 64. And again, we're not going to forget our units, which were meters squared. So hopefully you're noticing a pattern with these two, right? We're using the given information to draw in our triangle. And then based on the central angle, we're finding the missing side lengths in our triangle. Once we do that, then we look at the number of triangles that are congruent that it would take to get the whole figure. So for a triangle, we're going to use 3. For a square, we're going to use 4. All right, and then we're just going to plug into that formula. So before we do the pentagon, let's go ahead and do the hexagon. So for this one, the central angle of a hexagon is 60 degrees, which means half of 60 is 30. So now this is a 30, 60, 90. And we were told the apothem is 9 inches. So now go ahead, take a pause, find the 2 missing side lengths in this triangle in green, and then come back to check your work. All right, so you should have gotten, for the short leg, 9 over root 3 times root 3 over root 3, because you cannot leave a radical in the denominator. So you end up with 9 root 3 over root 9, which is 9 root 3 over 3, which simplifies to 3 root 3. So we know this is 3 root 3, which means next to it is also 3 root 3, making the entire base 6 root 3. And then to get from the short leg to the hypotenuse, I multiply by 2, and 3 root 3 times 2 is 6 root 3. So then from there, we are going to look at the number of triangles formed. So because it's a hexagon, there are going to be 6. So the total area of our hexagon is equal to 6 of those triangles. So again, we can plug into our formula. We have 6 times 1/2 times, and again, now we're looking at that whole triangle here, right? The whole thing. So times base times height. 6 times 1/2 times the base, which is the whole length here that I'm highlighting in green, which is the 6 root 3, times the height of that triangle, which we were told is 9. Again, I would probably cancel the 1/2 into the 6 to get 3, and then I would do 3 times 6 is 18. 18 times 9 is 162. 162 root 3. And then we're looking at our units, inches squared. So you can see here, right, with these 3 different examples that we've done, we needed to use what we already know about special right triangles. So now let's look at the pentagon, because this one is a little bit different. So for this one, we are going to first, again, start by finding the measure of the central angle. The whole central angle is going to be 72 degrees, which means this part is 36 degrees. And I was given that the radius is 12 kilometers. Now we need to find this distance, which we're going to call x, and this distance, which we're going to find y. So now think, we cannot use special right triangles, so we're going to have to use, hopefully you said in your head, sine, cosine, or tangent. So now take a pause and find the values of x and y in terms of sine, cosine, and tangent, or whichever one you need here. All right, so to find x, I'm going to need to use sine, so I'm going to have the sine of 36 degrees equals x over 12. And when I multiply both sides by 12, I get 12 sine 36 degrees equals x. And I'm going to leave it like this because we cannot round in the middle of a problem. We have to make sure that we are not rounding until the very end of the problem. So now let's do y. So y is not sine, it's going to be cosine because it's adjacent. So we have cosine of 36 degrees equals y still over 12. So we have 12 cosine of 36 degrees equals y. So now that we've found this, I want to look at my whole triangle, right, in pink, which means I need not just 1x, but 2x. So if I multiply both sides by 2 down here to get 2x, I multiply the 2 just into the 12 to get 24 sine of 36 degrees, which equals 2x, which is the base of the triangle. All right, so I multiplied x by 2 to get the whole base here that I'm highlighting in green. And when I multiply 12 sine of 36 by 2, only the 12 gets multiplied by the 2. The angle that we're referencing does not change, right? This is still a 36-degree angle. All right, so now that we have the base and the height, we can plug into our formula. So it's a pentagon, so we know the area of our pentagon is equal to 5 triangles. So I'm going to have 5 times 1/2 base times height. And we're going to plug in these expressions that we have for x and for y. So I have 5 times 1/2 times the base that we found is this 2x here, which is the 24 sine 36, right? That is the base of our triangle. So I'm going to type in 24 sine 36 degrees. Then times the height, which is my y value, which is 12 cosine of 36. 12 cosine of 36 degrees. And now that we have written this all in one long line, we can reach for our calculator. So now go ahead and grab your calculator and type it in, and then I will come back and I will show you what we got. All right, so hopefully you just typed it in your calculator. Let's look. You can do 5 times, I would do 0.5 for 1/2 times 24 sine 36. Make sure you close your parentheses, times 12 cosine of 36, close your parentheses, enter. And if you remember correctly, we needed to be accurate to 3 decimal places, so we're going to do 342.380, and this is kilometers squared. If you have questions about how to type it in your calculator, we will practice this next week. All right, let's go ahead and continue on to the next page. So go ahead and find this example on the bottom of page 6. We're redrawing this triangle here so that it is oriented in a more user-friendly manner. So right now I need you to find and label. We're given each of our radii are 4. And then we were told that this is a nonagon. So please find the measure of the central angle, which is going to be 360 divided by 9, which is 40, which means then each of these angles is going to be 20 degrees. All right, and then let's label x and y, and then go ahead and set up, take a moment, pause, set this up and do this problem on your own, and then come back and we will talk through it. All right, so you should have just gone through and been able to find that your 4 sine of 20 gets you x, 4 sine of 20. All right, and then when we want to find 2x, that's 8 sine of 20. So I can label that down here. The whole base is 8 sine of 20 degrees. And that y is 4 cosine of 20. Now you can plug into, so this is a nonagon, so our area is going to be 9 triangles. And now you can plug in to your formula. So now if we look, we should have 9 times 1/2 times the base of the whole triangle, which is x times 2 to get both of these pieces, which is the 8 sine of 20. 8 sine 20 degrees times the height, which is y, times 4 cosine of 20 degrees. And now you can type it into your calculator, and look, you should have gotten 46.281 units squared. We will do more practice on this next week. Homework is in the textbook. Have a good weekend.